This is a lot like question 2 on your test. In that case, I asked what I cubed did geometrically. What did I cubed do geometrically? Very good. So what is it going to do if I just multiply by the I? Very good. So this right here is a counter clockwise 90 degrees. Right? Every time I multiply by the I, it's going to be another 90 degrees. And then what did the conjugate do geometrically? Of which part of the complex number? The real or the imaginary? The imaginary. So if I have a graph, and let's say I have A plus BI. So hypothetically, let's say this is A, which is my real part. Let's say this is BI, which is my imaginary part. So this is where I'm graphed, correct? So then my conjugate would just be, so this is Z. My conjugate, remember, it's the line above it. That just means conjugate would be what? A minus BI. So what part changed? The BI, which is what part of the complex? The imaginary part. So if I had to graph it, my A is still here, right? But now negative BI is down here. So this is where the new graph would be. So this would be where Z's at, bless you, and this is where Z's conjugate at. Graphically, how would you describe that? Not flip, but not mirrors. What's another word? Reflects. Very good. So this reflects across the x-axis. All righty. So the conjugate geometrically just reflects the original point across the x-axis because the only part that's changing is the imaginary. And this is what we're going to be talking about today. We did a lot of math in the last couple of lessons. So now we're just going to look at it graphically. What is it doing to the original part? All right. So everyone got this written down at least? All right. These are good notes to have, guys. So make sure you're writing them down. So again, geometrically, if you want a picture here, if I was here and I multiply by I, this is where I would be. So that's 9 degrees clockwise. Bless you. All right, while I'm waiting, I squared would be, how would you write that out geometrically? Good, it would be a counterclockwise 180 degrees, and then geometrically, it would look like this, which is where negative, or where I squared is. But then we know that I squared is equal to just -1. So this would be 180 degrees, right? And then so on and so on. If I did it for a third time, where would I fall? 270. So again, I cubed would be 270. What about I fourth? 360. Very good. And then I5. Yes, in a sense, but it's actually another 360. So it'd be 450 degrees. Because you would have to, you go one full revolution and then like a quarter of another. But that's the main part. And we did this, I think, lesson 6, lesson 7, somewhere around there. But this is just review. Questions? All right. Make big question here. All right, what I want you to do real quick is now go to your workbook and think about and answer question 1 on the exercise. We just talked about the conjugate reflects it across the x-axis. What would I have to do? Think in your head, don't think out loud. On exercise 1, what do I have to do to the complex number to reflect it across the y-axis? Don't say it out loud, though. We are on page 35. Exercise 1 is the only one I want you to do. So the question's basically asking, what would you have to do to a complex number to reflect it across the y-axis? One more time.
These are all done.
Okay, let me regrade it at the end. Yeah. Yeah, just resubmit it at the end of class. All right. I couldn't figure it out. All right, do we all got an answer? What do you think you need to do to reflect it across the y-axis? Yes, ma'am. The y-axis, yes. Go ahead. Very good. We need to change the sign of the real number. So change the sign of the real number. All right. So in a sense, if I start off with z equals a plus bi, and I wanted to reflect around the y-axis or the imaginary axis, it would then need to become a what? Very good. All right. All right. What this is actually called, here's some notation for you, is the negative of the conjugate. So this right here is called, I say the negative, it's actually called the opposite. So that's what they use for negative. Opposite of the conjugate. So here's some new notation. Never, I spell this out every day and I don't. So J or G first? Thank you. All right. I don't know. I don't take off for spelling. But now you're going to see, and so we know that the Z with the line above it represents the conjugate, but now when you see a negative in front of it, it's going to represent the opposite of the conjugate. So instead of it reflecting across the x-axis, will now reflect across the y-axis, or also known as the imaginary axis. Questions on that? All right. So what I want y'all to do real quick then with that new notation is now I want you to do number 2, and I just want you to graph all those. I want you to graph W, Z, W plus 2, Z plus 2, W minus 1, and Z minus 1. And they gave you a graph, didn't they? Yes, perfect. And again, remember that the x-axis is known as the real axis, and the y-axis is now known as the imaginary axis. Yeah, I don't either. Oh, they went by 2s. But you can extend it if you like. Yeah, that's what they went by, but it doesn't matter to me. If you extended the graph, that still makes sense to me. I feel like they should have noted that though. Anyone need help graphing? Yes, sir. Good. I know you're out Thursday, but you're good. So W, good, left 4, up 3, perfect, you got it. Good. One more time, David. Well, when you combine like terms, where would the +2 go to? The real. So you would add 2 more to the real. So if you need to, write out the arithmetic part of it. This is -4 plus 3i plus 2. So when I combine like terms, this now becomes -2 plus 3i. Mm-hmm. Yeah, resubmit it at the end of this class period, and then when I find some time at midnight tonight, I'll get it, I'll grade it and put it in there. All right, we got it all in or graded. We have it all graphed. We got a little more time. I still see some pencils moving. All right, let's review real quick. What is W as a coordinate? All right. You don't have to do this step, but this allows you to kind of see that you need to go to -4, which is right here, and then up 3, which is about right here. And then we'll just label it with W. I saw in some of y'all's assignments, y'all just labeled it with like the letter it went with of the part. That's fine too. I get it. All right. Questions? Pretty straightforward. All right. Doesn't get much harder than this today. Z would be what as a coordinate? -5, very good. So I'm gonna go right 2, then down 5, which is approximately right here. Everyone's still good? All right. So when I add 2, if you don't know where to add it to, just write it out like I did here. I wrote the W out plus the 2 so I could see that I'm combining like terms to my real number. So what's the new coordinate here? It's like that. That's exactly what it's like. That's very good. All right. So this right here would be my W plus 2. D plus 2 would be what? What would the coordinate be? Good. I'm just going to add 2 to the real part. So that's 4 comma -5. So I went right 4 down to -5. This is now Z plus 2. W minus 1 would be what? -5 comma 3. Very good. So I'd go left -5, up 3. So this would be W minus 1. What's Z minus 1 going to be? Very good. So I'd go right 1 down -5. So I'd be right here. So that's going to be Z minus 1. Questions on any of this graphs? Go ahead and take a moment to answer number 3. And you're just writing out, describing what you saw when you had to add or subtract to these complex numbers. So what did you see when you had to add or subtract to these complex numbers? Yes. Oh, LOL. Sorry. It was funny when I was grading it. Sorry. Yeah. I'll put a smiley face with a laughing emoji. All right, we all got our descriptions. So when I'm adding, subtracting, what am I adding, subtracting to? The real number. So when I add or subtract to the real numbers, what did it do graphically? The x-axis. But what did it do? What did you visually see it happen? Good. It moved it left and right. So this is your conclusion then. And it can be generally like this. But if you add or subtract real numbers, it will shift the complex number left or right. Now let's get a little bit more specific. What did I do to the complex number when it shifted left? Okay, so this would be more specific if I subtract a real number, then it went left. What did I do when it shifted right? Add. So this is, if I add a real number, it shifted to the right. All right. So this kind of makes a little bit of sense when you're talking about your transformations from way back when in Algebra 1, Algebra 2, probably in Geometry 2, and all of your stuff. Anytime we added or subtracted something outside of the function, we always saw it do what? Move left and right. All right. So that kind of applies in the same approach. All right. So now let's go to number 4, and I want you to graph those. But notice, what are you adding or subtracting this time on number 4? I's. What do you think is going to happen? Let's make sure that works out. So go ahead and graph those and see what we visually see on number 5. Oh, sorry, my bad. Number 4. Number 4. According to them, yes. They went by 2s. I think that's my favorite. Takes me back to my childhood. It's like drinking an icy. Mm-hmm. As long as you don't get anything on the floor. Good. y'all ready? Okay, give you a little more time. Now we got it. So notice that the W and Z is the same as number 2. So that was still -4, 3. And then 2, -5. If I had more time in here, I would love to show you using Desmos on this, and it's really cool to see the effects. If we got time, we'll do some more. And then again, just like before, take your W, which is -4 plus 3i, add the I, then you can see that when you combine like terms, it's only changing the B term of the a complex number. So it goes up to -4, 4. So that'd be -4, 4. This will be W plus I. Right. And then after that, hopefully you then tell Saul that it's really just adding to the B. So therefore, what's D going to be? Good. 2, -4. So I'm going to go 2, -4, which is here. This is what Z plus I does. What's E going to be? Very good. So I go -4, -1. Oh, -4, -1. This is now, whoa. Let's see, -2 plus 3. Yeah, it should be +1. And if you have 3i and you subtract 2i from it, it should be at +I. Yeah. So that'd be 2 minus 2i. But you said it so confidently, I thought you were just correct and even question it. All right, so then what's F? 2, -7. So this goes 2, 4, 6, like 7's like right here. So that'd be Z minus 2i. All right. So if you haven't already, go ahead and answer number 5. Tell me in your own words, what did adding and subtracting the I do to the complex number? Yes, ma'am. All right, do we all got it in words? I'll give you a little more time. All right. So what did we notice when we add or subtract imaginary numbers to a complex number? It shifted it up or down. Very good. So when we add, subtract, imaginary numbers to a complex number, we we shift. That's not us. We shift up or down. So what did I have to add to make it go up? Oh gosh, what did I have to do to go up? I had to add. So we're going to add an imaginary number. What do we have to do to go down? Subtract. Right? All right, so any questions on that? All right. So let's explore about some things. Let's go back to our journal. All right. If z equals -6 plus I, oh, so sorry. You could probably do this right on top of your warm up, but this will be lesson 9. The geometric effects of complex arithmetic. All right. So again, if z equals -6 plus I and w equals 2 plus 5I, how would you describe the effects of adding w to z? Just looking at that without doing any work, what do you think you would describe the effects of w added to z? I like your way of thinking. Let's see if Luke is correct. So if I have a graph and I go this, what's z's coordinate? So it'd be -6, which would be a 1 plus I. So it'd be -6, comma 1. Yeah, this is z in itself. We're not adding something to the z yet. So if I graph this would be 1, 2, 3, 4, 5, 6, up 1. So this would be my z roughly. Right? Now with arithmetic, if I wanted to figure out what z plus w is, I would literally just go -6 plus I plus 2 plus 5I. And how would I simplify that? Good. I would add up my reals. So -6 plus 2 is -4. Add up my imaginary. So what's I plus 5I? 6I. And typically what we would do is in the past, I would call this like a different letter. I don't know, let's call it X or whatever. And then I would go graph that. So I would go, all right, well, -4 would be 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 1, 2. And this would be where X would be, right? But I want you to describe how I went from there to there. And what would you say? You went right. How many units? 2. And then up how many units? 5, right? But without actually having to do this work, I can just look at the characteristics of W. I just found out when I add real numbers, it shifts it left and right. And if it's a positive and I'm adding right 2 units. And then I just saw that if I add or subtract imaginary, that makes my thing shift up and down. And since it's a positive, I went up 5. So we don't necessarily have to now do the arithmetic. We don't necessarily have to graph it. You should be able to just go from here, see what you're adding and go, all right, this is 2 units right, 5 units up. Now, necessarily, if you don't see that, you can graph it because this went 2 and then up 5, or you can do the arithmetic to see where you land as well. All right? But this would be what the effects of adding W would be. So there's 3 different approaches to this. All right? Any questions on that? All right. This next one I want to get into. So let's do it. Let's look at the example in your workbook. Let's go back to our workbook. I think they gave you plenty of space for it. They give you a lot of space, about half a page. That'd be plenty. I debated about this one, but I think it's going to be good. Y'all be my guinea pigs to see if I do it for sixth period. All right, this one says, given the complex number z, find a complex number w such that z plus w is shifted square root of 2 units in the southwest direction. All right? This is an SAT question. All right. All right. This is what they want you to do. All right. So here's your graph. So you're given a function z. Right? You don't really know where it's at. Let's throw it over here. It's not going to matter. You can put it in any quadrant you want. You can put it in the center if you like. And it says we're going to find a complex number w such that when I add it to my z, it is shifted square root of 2 units in the southwest direction. If you don't know your compasses, never eat sour worms is how I remembered it. I think someone does soggy waffles. Sour watermelon, however you remembered it, draw out a compass, and where would the southwest direction be? That way, right? Oh, well, I guess, oh, sorry. You're reading that one. I'm over here. Yes, that way. We'll just, I guess I'm seeing in this direction, but it'd be this direction. This is your southwest direction, all right? So that means I need to shift this unit right over here. I don't know how much, but this would be right. What would then that shift be called? If I'm trying to figure out what my W is, what would this guy be considered? It is my vector, and vector does two things. What are the two things it does do? Oh, that's the same thing. Direction. Our direction was the southwest direction. What was the distance? Square root of 2. All right. Now, I don't know how much we had to add to the W, but we're going to cut the distance in half for both left and down. So I'm just going to call them both X. Whatever they're going to be the same amount of left and down, just to make the math work out. If I'm now trying to figure out what those X's are to figure out what my imaginary and real number is, what does this look like to you? A triangle. And how do we solve triangle sides? Good. The a squared plus b squared equals c squared concept, the Pythagorean theorem. Well, I don't know my a and b, but I want them to be the same, so it makes out my math work out. So this is now x squared plus x squared equals, what's my c? The square root of 2 squared. 7 plus w. That's a z. That's why there's a line through it. Right here. We don't. This is an SAT question. It says you are at z anywhere on the graph. It doesn't matter where you are. I could put the triangle over here. The math is still going to math. And I want to add a w to this z in a southwest direction. So that means I want to go left and down, right? But I want to add it in a sense that when I go in this direction, it travels square root of 2 units. That is what we call our, oh, that's an H. That's our magnitude. That's the distance. That's your C when looking at a Pythagorean theorem. So this will be your C. And since I want my A and B to be the same, this is going to be my A, and this is going to be my B. It doesn't matter which one you label A and B, but because I don't know either one of them, I can just split it down the middle and let A and B equal the same values. Right? So the setup of this question is the same setup every single time. It's going to be your hypotenuse. In both of these are going to be X. The only thing you got to pay attention to, other than just the math, is know what direction you're going to go, because that's going to matter. What do I know? If I'm going in the southwest direction, what kind of sign does my A and B need to be for my W? both negative. If I'm going left and down, I know they're going to be some type of negative results. I just don't know what they are yet. Right? So when we work this out, what's x squared plus x squared? 2x squared. I just have two oranges here. I'm adding together and I have two oranges. What's going to happen to the square root and the square? It cancels out, leaving me with just 2. Algebraically, what would you do next to solve? Divide. Now I get x squared equals what? What's 2 divided by 2? 1. And what's the square root of 1? Oh, my bad. I guess I should ask this. How do you get rid of a square? Square root it. Square root of 1 is not I. What is the square root of 1? Just 1. What is I represented by? Square root of negative 1. All right, so I get x equals 1. All right, I know typically we have to do this plus or minus concept, but since I know it's going in the southwest direction, I know my a and b are both negatives. Why did you? So, okay, so what is x plus x? What is x squared? X plus x? So when you are adding, we're only adding the coefficients. So I just add the 1 and 1. When I multiply, now I'll add, so x squared plus x squared. Since I'm adding, I just add these coefficients, giving me 2x squared. If I'm doing x squared when I'm doing x squared times x squared, now I can add the exponents and I get x to the 4th. So when you're adding, you're just adding the coefficients. When you're multiplying, now you can add the exponents. So that's why this stayed as 2x squared. Any other good questions like that? All right, so since I know these are both 1, I'm just going to write this now as a complex number. And how would I write this as a complex number? Negative 1. Good, minus I. If you wrote plus negative 1i, I wouldn't count off, but you realize that this means negative I. So there is your ultimate answer. This math is done every single time. It's always going to be x squared plus x squared equals something. So it's always going to be 2x squared equals your magnitude squared. And then you can just work it out from there. So you can actually technically start from right here if you wanted to. Okay. Any questions? I thought that might be a good one. Right. So to conclude, these are the things, I think it's in your closure. Do you have closure on yours in that box? On the top right, the little box there? Yeah, so here's so again, to recap, I'll highlight the important things for you. So there's your lesson summary. So the conjugate of z, again, this is a kind of a review, reflects across the real axis. Right? The conjugate of z reflects across the x-axis. The negative conjugate, or also known as the opposite conjugate, which is now labeled like this, reflects across the imaginary axis. So it reflects around the imaginary axis, also known as the y-axis, and this was also the x-axis. All right, all important. When we add or subtract real numbers, we saw it shifts left or right. When we added or subtracted imaginary numbers, we saw it shift up or down. That's the biggest takeaway. Go ahead. Opposite. Sorry, that's opposite. We only have 4 minutes remaining, right? Yep, we sure do. All right, any questions there? All right, so on the problem set, I only want you to do number 1, all right? So just given Z and W, plot the following points in the plane. Is this plane by 2? Huh? This one went by ones. Yeah, this one went by ones. It looked like it fit everything in there. But that is your, I guess, your homework or assignment. It's just the first one. If you want to challenge yourself, you can do the rest of them. You should be able to do all of them, but at least do the first one.